Welcome to Study Loop.
19.93, we have this circuit here. Initially the switch is down so that C2 is fully charged to the voltage V0. And then we imagine flipping the switch up so that C1 and C2 are connected to each other. And we want to find the charge on each capacitor after that happens. So the initial charge on the capacitor, which is going to have to be the total charge, because when we connect the two capacitors together, there's nowhere for that charge to go or anywhere for it to come, any extra charge to come from, except for what was on C2, because C1 and C2 will be connected together and not to anything else. So that's going to be C2 times V0. And now when they're connected together, because they're in parallel, the charge is going to redistribute itself so that the voltage across either one is equal. So there'll be some voltage V, and that's going to be equal to both Q2 prime, the new charge on capacitor 2, divided by C2, and it also must be equal to Q1 prime divided by C1. And so we can ignore the voltage here and just rearrange the second equality here. And we see that Q2 prime will be equal to Q1 prime times the ratio of the two capacitances. So we have this, and now we also know, like I said, that the initial charge has to equal the sum of the two final charges, again because there's nowhere else for any charge to go or to come from. Q2 prime now this is also going to be C2, or Q2 rather, prime, which we already know is Q1 prime times C2 over C1 plus Q1. So this is the charge on capacitor 2, this is the charge on capacitor 1. And so then the total charge is going to be Q1 prime times C1 plus C2 divided by C1. So now we have this in terms of the charge on capacitor 1 and the capacitances we know is equal to the initial charge on capacitor 2, and we know that that's equal to C2 times V0. And so then just dividing by C1 plus C2 divided by C1, we find that Q1 prime is equal to C1 times C2 divided by C1 plus C2 times V0. And we know Q2 prime is Q1 prime times the ratio of these two capacitances. And so we'll get an extra factor of C2 up here, and the C1 will cancel. And so we have C2 squared divided by C1 plus C2 times V0. So this is the charge and the final configuration on either capacitor.